In Segment 3, I will discuss network architecture, routing and addressing, performance architecture, security, network management, and network design. This slide demonstrates the network topology for Champions Community College. It is an access distribution core topology. Also shown in this slide are the hard and soft network boundaries. Connections between the buildings are soft boundaries. The router at the edge of the CCC network is a hard boundary for the college. CCC is an autonomous system. Routing strategies connect the Bowman campus to other autonomous systems within the USCCS enterprise network. Routing flows for Bowman are segmented by functional areas and work groups. There are 3 work groups in Foundation Hall and 3 in Wrights Hall. The work group designated for the digital signage network spans both buildings. The Bowman campus is considered a stub network. A static route is used on this path. External border gateway protocol is in use on the other side of the router. The router is managed by a third party. Internal IP addresses are used at CCC whenever possible. This addressing scheme not only saves public IP addresses for necessary functions, but also adds additional security to the network. The table below shows a suggested addressing scheme for the workgroups in Wrights Hall and Foundation Hall, as well as for the digital signage network devices. Performance architecture is limited on the Bowman campus. USCCS network administrators have ultimate control for performance architecture strategies for the enterprise network. Based on previously identified network priorities, Burby Alert software receives first priority. Alerts entering the network are critical for safety. As such, network prioritization, traffic management, scheduling, and queuing are crucial for these packets. diffserv is utilized using an IP DSCP byte. The router and all network switches recognizes the byte as priority 1 and schedules delivery using class-based queuing. Priority flows are shown on this slide. Flow 2 is designated for voice over IP traffic, and cameras are designated as flow 3. Voice over IP traffic has 1 megabyte of bandwidth reserved for its use. The current project has several in-depth evaluations on security risks, including how these risks are dealt with on an ongoing basis. The diagram below illustrates the various security zones identified at CCC. Zone 1 encompasses all network devices. User security is applied at this zone. Zone 2 represents the security provided to devices that use NAT addressing. Zone 3 are classrooms as well as general access machines that are protected from intended or accidental software changes. No change survives a reboot of the machine. Zone 4 illustrates explicit permissions needed to perform tasks within PeopleSoft. Zone 5 encompasses the wireless access points that utilize WEP encryption. Network perimeter security is managed by a third party. Firewalls perform packet filtering such as source and destination addresses and port identification. The network does not utilize intrusion detection or intrusion prevention systems. Switches are also monitored by a third party. We next look at flow security. Domain controller traffic is encrypted. Computers used as domain controllers are replaced frequently to ensure that less secure legacy encryption is not used that can be trivially cracked. Access to many systems is secured using SSL. Of note, if the local domain controller is unavailable, requests to other domain controllers are secure. We next move to network management architecture. According to the USCCS Network Manager, an in-band management model is used for WAN monitoring. A distributed model is used. When WAN links exceed 80% of capacity, an email is triggered and an investigation for possible causes begins. The group who monitors network switches use event logs, traps, and SNMP polling. When events are raised on CCC switches, third-party representatives contact local IT departments to investigate possible causes. Locally, servers are monitored primarily by event log events. Over the next 2 slides, we will look at 2 more logical views. One will be of the servers at Champions Community College, and the other will be a logical view of the digital signage network. This is a logical view of the servers in service at CCC. The view includes a media server for the digital signage network. It will have a Windows 2008 operating system with a gig Ethernet network card. The next view is a logical view of the digital signage network. In Wrights Hall, there will initially be one digital display located in the student union. The media player will send data to the display for viewing. It is connected to a network switch in the comm closet of Right Hall. In Foundation Hall, 2 displays will be installed. One will be a large screen and one will be a room sign device. The room device has its own media player. The display will also have a media player for storing and serving programming. A media player is capable of showing unique content. By having 2 media players, content in the student union may be different than content showing at Foundation Hall. This view also demonstrates the digital signage media server that will be placed in the IT department in Foundation Hall. On this slide are 2 maps showing the locations where the digital signage displays will be installed. In Foundation Hall, the large display will be mounted in the lobby of the building adjacent to the Student Services area. The room display will also be in this area. The Student Union is the location selected for the digital display in Wrights Hall. Vissix Incorporated is recommended as the vendor for the digital signage software, channel players, and small room display. NEC commercial LCD monitors have been priced for this project. Many displays are available, however, a commercial-grade display is highly recommended. Commercial displays are built to operate for long periods of time and are able to adequately dissipate heat. Consumer-grade displays are not recommended. The room sign comes equipped with a media player specific for that purpose. The room size is a 15-inch display. Other devices needed for this project include a server for media storage and the digital signage management software and publishing software. The IT department has excess server capacity for the initial project launch. Channel players. A solid-state device is recommended. It is less susceptible to damage as compared to traditional moving disk hard drives. Channel players are equipped with video cards capable of handling high-quality display demands. Many channel players are capable of wireless connectivity to the LAN. Gigabit Ethernet cards are recommended. In future stages of this network project, switches may be necessary and perhaps a server for more storage capabilities. According to the IT director, a budget of $25,000 has been given for this project. Below is a breakout of anticipated costs. Highlights of the budget include 2 46-inch commercial-grade LCD monitors, 1 room display media player and monitor, content management software including licenses and maintenance, 2 solid-state channel players, 2 wall mounts, training and support. An estimate has also been done on recurring costs, including software maintenance for the content manager and the media players. A budget line has also been included for anticipated personnel costs to maintain the network both technically and creatively. Finally, an estimate of future hardware expenses is also provided. The Digital Signage Network project will require an estimated 3 weeks to complete. Collaborative efforts will be needed between the Maintenance and Operations Department, the Marketing Department, and the IT Department for this project to conclude on time. A Gantt chart has been developed to illustrate task dependencies. Work by the Maintenance Department must be completed before the IT Department can install the displays in the channel players. The server must be provisioned before the Marketing Department can begin storing data on the server. The Marketing Department must complete at least some content to test the display network. Content testing and training on the system cannot be done until all other tasks are successfully completed. Over the past 30 minutes, I have described for you the current network at Champions Community College, as well as information regarding the addition of a new digital signage network to the Bowman campus. Improved communications has been identified as a priority for students and employees. The successful launch of the digital signage network and its continued growth will be one tool for improving communications, enhancing visitor experiences, and removing messy clutter from around the campus. It has been my pleasure to meet with you today to present the project to you. Please see the project report for more details on all aspects of the project.